Hi, and thanks for joining me for this discussion on forecasts.
What meteorologists typically call guidance is computer-generated products that meteorologists use for forecasts. They look at these output and these maps, and from that come up with their forecasts.
There are two very general categories of tools that meteorologists use in making forecasts. The first one is numerical models. We'll be discussing this in this video.
This video will discuss numerical models, and specifically we're going to look at an overview of numerical models. So numerical models we've talked about already, but they are basically simulations of the atmosphere using the physics of the atmosphere, time stepping into the future to predict what will be down the road. And these are mathematical simulations. These numerical models can be put into several different types of categories. Categories that classify their domain size, their resolution, the physics of the model, how they time step into the future, and even the different types of models. What we mean by domain size is how big is the forecast area? Is it looking at the entire globe, or is it just looking at a few states? Resolution, meaning what's the smallest feature that can be resolved in the numerical model. The physics deals with how things are handled, how different physics or different types of phenomena are handled in the models. When does it rain? When are clouds formed? How does radiation affect the model? And then time stepping means how often does a forecast get made? Are you looking at a time step or a forecast every hour, every 3 hours, every 6 hours into the future? And then how far out does it go? Does it go out to 3 days, 10 days, 14 days? And then the types are a little bit complicated. They deal with some of the physics and also how the model handles weather features. Is it on a grid or is it in the form of a wave? So first we're going to talk about the numerical models that are performed or created by the United States. And these can be basically categorized according to duration. Short-range models typically go out about 3 or 4 days, whereas medium range can go out to perhaps 10 days. And there are a number of different types of models. Short-range models include the RAP, the HER, and the NAM. And the medium range, we have a GFS model, which is our primary medium range model. First, we'll talk about the RAP. RAP is a short-range model, the rapid refresh. It's been around since probably about 2005 or 2006. It's the primary model that we get a lot of information from, specifically short-range information. Of course, you'll see a lot of the RAP products are created at the Aviation Weather Center. So the RAP runs every hour, and it's updated every hour, and it time steps out into the future 1 hour at a time. And it runs a very short period of time, out to 18 hours. It has a relatively good resolution, 13 kilometers. That means it's a grid point model. They put a grid on the Earth, and every 13 kilometers there's a 13-kilometer box, and at the corner of those boxes are points, and it forecasts information for those points. Another short-range model is the HER. The HER stands for the High Resolution Rapid Refresh. It has a much greater resolution than the RAP. The RAP has a 13-kilometer resolution. This takes it down to 3 kilometers. So you can think of the HER as an improvement on the RAP. Like the RAP, it's run every hour. However, instead of an hour time steps, it time steps out every 15 minutes, which means it's much higher resolution. But it still goes out to 18 hours just like the RAP. The HER is very good for looking at convection. If you want to see where convection is going to form, they have a simulated reflectivity, what the radar reflectivity would look like out into the future every hour. And I recommend that if you're wondering about thunderstorms, you take a look at the HER. The NAM is one of our most used computer models or simulations. It's a short-range model, meaning that it goes out to about 84 hours. It's run 4 times a day. It's run at 0, 6, 12, and 18 Zulu. It takes 3-hour time steps. The resolution actually is pretty good. It's got a 12-kilometer resolution. The NAM is one of our workhorses, meaning that it is used quite frequently for forecasting, especially out to 2 or 3 days. The GFS is one of our workhorses also. It's a medium-range model. Typically, it runs 4 times a day at 0, 6, 12, and 18 Zulu. It runs out to 16 days, which seems a long time. Really, you can only trust it out to 10 days. Typically, beyond that, it'll pick up large weather systems, but it'll make them really stronger, and they look really strange. So you don't trust it out past a week or 10 days. Time steps out 1 hour at a time for the first 5 days, so it actually picks up things pretty good, weather systems pretty well. And then the first 10 days also, it has good resolution at 13 kilometers. After that, things kind of degrade. There are a lot of other models here in the United States and also elsewhere. Some of the ones that are more popular are the Canadian GEM model and then also the European model. The European model had the distinction of correctly forecasting Hurricane Sandy back in 2005, or was it 2006, whereas the GFS had it going out to sea. Now we'll look at sources of numerical model data. In the United States, most models are run at the National Center for Environmental Prediction's Central Operations, which is located just outside of Washington, D.C. in Maryland. NCEP has high-speed computers that can do tera or petaflop operations, and they're just incredible machines. So it's not everybody has a supercomputer at home. So that's why NCEP runs all the computer models, and then they take the output and provide the computer output of the models to whoever wants to plot the information. They, in fact, themselves plot the information, but then they distribute it freely, and other people can plot it and put it on their web pages as desired. So this is NCEP Central Operations' own website, and this is, you can think of it as the source of model data. This is where they plot the information. You can look at it, different model areas or domains across the world. And then they have all the different types of models, whether it be the GFS, the NAM, and then there's several other different types of models that we didn't even talk about. Some places that take that model data from NCEP and plot that information for visualization or for looking at is NCAR, the National Center for Atmospheric Research. They have an excellent web page, and they have 3 different models that you can look at. You can look at output from the RAP. You can look at information or guidance from the NAM, and then also from the GFS. The College of DuPage takes this information also, and they have a very good website that allows you to look at HER data, RAP data, NAM data, and also GFS. And I think they also have a link to the Euro.
Pivotal Weather is another great site for weather information. They plot several models out there, including the HER, the RAP, the GFS, as we talked about. But they also have Canadian models, and they also have European models. And they have different types of ways to display the information, to loop the information, and compare it to other models. Really good site. So all of these sites plot constant pressure charts, and that's what meteorologists tend to think of. They tend to think in terms of what different layers in the atmosphere have different types of weather phenomena. And they put on these charts contours, which are lines of constant height. They also forecast on these the wind at that given location on this chart, also relative humidity, and then other parameters such as temperature or other things. If you've already forgotten the standard levels for pressure surfaces in our atmosphere, they start in the lowest layers of the atmosphere at 925 millibars, and they go all the way up to 200 millibars. Actually, the models do forecast above 200 millibars, and they also do plot surface features at the Earth's surface. But these are the standard levels that meteorologists typically look at. What good are these constant pressure charts? Well, we can look at these charts and start to figure out what kind of weather patterns there are, what's affecting the weather. So they also give us the winds and temperature law forecast that we see at the Aviation Weather Center whenever we plan for our flights. And also, they help us identify where there's ridges, troughs, highs, or lows, which can produce either good or bad weather as they move across the United States. Here's some examples of constant pressure charts. Specifically, this is the 12Z forecast. It's 12 hours into the future, actually. And this looks like an 850 millibar map. The solid lines are contours, which represent the height of this pressure surface. So it varies. Where it's colder, it's closer to the ground, and where it's warmer, this pressure surface is higher above the ground, or actually above sea level. Also, the green areas are relative humidity, so it kind of gives you an idea where there might be some clouds at 850 millibars. And also, if you look really close, you might even be able to see some temperature lines. Here's another chart. This specifically is the 500 millibar chart. And this is showing, once again, contours, those lines. You can see the winds being plotted on this also. And these yellow and orange areas are vorticity, which meteorologists use to anticipate where the air is converging and diverging in the upper atmosphere. And here's another chart. This is a 300 millibar chart, about 30,000 feet. So the darkened blue and aqua green areas are showing where the jet stream is, the maximum in wind speed. And you can also see across the Colorado Rockies or the Western Rocky Mountains from Montana all the way down, well, even for that matter, down into Mexico, that there is a really deep trough. And then across the eastern United States, there's a ridge. So that gives you a little bit of idea about numerical models and how to use them.